All right, hello. We are here to do the Algebra 1 LT8 practice quiz number 2. So let's go ahead and get straight into it. We're starting with our first golden standard when we're multiplying two binomials. The first thing that we're always going to do, always, is start by drawing your area model. So that area model, handy dandy little square with 4 boxes inside. What we're going to do is we're going to label our length and our width as our given binomials. So my length here is 5x minus 2. My width, also 5x minus 2. Then, to find the area of each of the boxes, multiply your length and your width. So for this first box, 5x times 5x, 25x squared. Remember your x times x. Remember those exponent rules. X times x is x squared. Then do the same thing for your other boxes. 5x times negative 2, it's negative 10x. Same thing down here. And the negative 2 times negative 2 is positive 4. What our final answer should be is area as a sum. So we're going to add up the individual areas that we just found. So we got 25x squared minus 10x plus 4. Then remember, we can combine our like terms. So here, I have negative 10x and negative 10x, which will combine to get negative 20x. So my final answer, 25x squared minus 20x plus 4. Same idea for the next one. We have x minus 5 times 4x minus 3. I'm going to start the same way. Draw myself an area model. Let's get that going. And then label my length and width. So up here I have x minus 5. Down here, 4x minus 3. Then we just multiply the same way we did. 4x times x is 4x squared. 4x times negative 5 is negative 20x. Negative 3 times x is negative 3x. And negative 3 times negative 5, positive 15. Write out my area as a sum. 4x squared minus 20x minus 3x plus 15. Don't forget, combine your like terms. We want to simplify as much as we can. So my final answer, 4x squared minus 23x plus 15. Awesome. So for the last question in this golden standard, we're going to have some quantity squared. What I want us to remember is what this square means. All we're going to do is use our exponent rules and expand. If I'm squaring something, raising it to the second power, that means I'm multiplying the same thing by itself. So if I expand this, all we have is 5x plus 3 times 5x plus 3. We're multiplying 2 copies of the same thing. And then once we write it like this, it's the exact same thing we just did in the last 2 problems. Draw an area model and get your length and your width, which in this case are both the same. And then we just multiply. So going through this, 25x squared, 15x, and positive 9. Same thing. Add up all of your terms. Area as a sum. 25x squared plus 15x plus 9. And then just combine your like terms. 25x squared plus 30x plus 9. It's the first golden standard, multiplying. Draw yourself your area models. The biggest hints I can give you right now. So let's go ahead and scroll down, look at level 2. So for level 2, we're factoring each polynomial completely. The first thing that we always look for whenever you see this word factor, greatest common factor. Look for your GCF. Some questions will have a GCF that isn't 1. Some questions won't. So in this case, what I'm going to do is I see 20x to the third power minus 4x squared. If I'm not sure what the greatest common factor is right off the bat, just break down each of these terms. 20x to the third power, well, that's just 5 times 4, and then times x times x times x. 4x squared, Well, that's just 4 times x times x. We're looking for the biggest thing that both of these share. So if I look, I see 4x and x, 4 times x here, and 4 times x here. So then my greatest common factor is 4x squared. And then what's left over is just what we didn't factor out. So from this 20x to the third power, we factored out 4x squared. So what's left over is 5x. So on the inside here, we have 5x. And then what's left over here? Well, we factored everything out. So the only thing that's left over is this invisible 1 on the outside, plus 1. 4x squared times 5x plus 1. And if I re-multiply this out, if I distribute this term, we'll end up exactly where we started. Except that I made a quick mistake. Don't forget, don't be like me. Don't forget that there's this minus sign here. So this actually should be 4x squared times 5x minus 1. See, if you check your answers, like I was just about to, you would see we need this minus sign. If we're subtracting these two terms, then this is a negative 4x squared. Don't drop your negative signs. Again, check your answers if you're not sure. Okay, so that's our first question. And then what we also want to look at is if we can factor this any further. If I could factor 5x minus 1, but this right here is as simplified as it can get. I can't factor this any further. So this is our final answer. So let's look at number 2. We have x squared minus 8x minus 20, and we're factoring it completely. First step, always first step, is there a GCF? Well, in this case, the GCF is just 1. I can't divide any of these numbers by something bigger than 1 evenly. So we don't really have a GCF here. So X that out. Then we're going to factor the same way we have been whenever we see these quadratic functions. Start with an area model and a diamond. Draw your area model, draw your diamond. Then on the inside of our area model, that x squared term goes in the top left, and that constant at the end, that negative 20, goes in the bottom right. Now we're asking the question, how do I split up this negative 8x into 2 separate areas? To do that, we use our diamond. So on the bottom, that negative 8x, that middle term, and on the top is that first term times the last term, negative 20 times x squared. Or if you want to think about it a different way, we're just multiplying this diagonal right here. Negative 20 times x squared is negative 20 x squared. So we're looking for 2 numbers that multiply to negative 20x squared and add to negative 8x. So in this case, we're going to end up with negative 10x and positive 2x. They add to negative 8, they multiply to negative 20. So in our area model, we can fill in these 2 terms. And it doesn't matter which box I put them in. I could put them like I'm doing right now, or I could have switched them. We'll end up with the same answer. Once we have our area model filled out, now we need to find what's the length and what's the width. If I know I have an x squared here, then I have to have an x and an x. They multiply to x squared. Now we're asking the question, x times what is negative 10x? So in this case, it's negative 10. And then ask that same question, x times what is 2x? Well, in this case, it's positive 2. So then our area as a product is x plus 2, that length right here, times the width of x minus 10. And again, if you're not sure whether this is the correct answer, remultiply, distribute your terms, and see if you end back where we started. You can always check your answers here. So that's level 2. Let's go ahead and flip this over. Take a look at level 3. Level 3 up here. Same idea. We're factoring each polynomial completely. This time though, going to highlight, this is also a golden standard. Level 1's a golden standard to multiply. Level 3 is a golden standard to factor. First question we are always asking, is there a GCF? In this case, there's no integer that divides 7, 6, and -1 evenly. So GCF, no. Okay, from there, we factor the same way we factor as always. Draw an area model and make a diamond. So in our area model, fill in the terms the same way we have been. That first term in the top left box, that last term in the bottom right box. Then we're looking for two terms that I can split 6x into. So we're going to use our diamond now. Down here on the bottom, we can put our 6x. And then up here on top, you're multiplying your diagonal, multiplying your first and last term. So here, -7x squared. Two things that multiply to -7x squared and add to 6x are 7x and -1x. So in our area model, we can fill in a 7x and a -1x. Now we're asking the question, what times what is going to get me this area? So to get to 7x squared, well, I know for this x squared, I'm going to have an x and an x. To multiply to 7, one of these has to be 7 and the other has to be 1. But the question is, does the 7 go on the side or does the 7 go on top? What you want to look for is, what do the other areas have? So if I put a 7 up top, for example, then that would mean 7x times something is -1x. But I can't multiply 7 by any integer to get to -1. But if I put the 7x over here, well, then I know 7x times 1 is 7x. So I have to have my 7x on this side. You could have also seen that by looking for the greatest common factor between this row. The greatest common factor of 7x squared and 7x is just 7x. The biggest thing I could divide both of those by. Okay, so if we keep going, we're looking for x times something to get -1x. So here, it's just -1. So my area is a product. My length is 7x minus 1. My width is x plus 1. And that is our area as a product. Same thing we did in the last question. The only difference is that there was a 7 out here in front. Again, if you're not sure, check your answer. Multiply it back out. Let's look at number 2. We got 3x squared minus 10x plus 7. First question, is there a GCF that isn't 1? Well, is there a number I can divide 3, -10, and 7 by? Not quite. I can't divide any of these three numbers by the same thing evenly. So there is no GCF. Okay, then draw your area model and make your box. Make your X. Up in the top, we got that first term. Down in the bottom, we got that last term. So up top in our diamond, 3x squared times 7 is 21x squared. And on the bottom, always put that middle term, -10x. You're looking for two things that multiply to 21x squared that add to -10x. So here, we're going to have a -7x and a -3x. Remember, they can both be negative. A negative times a negative is a positive. So in our area model, let's fill that in, -7x and -3x. And we're asking that same question. What multiplies to get to the inner areas? So in this case, I'm going to have a 3x up here and an x on the side. X times -7 gets me to -7x. And 3x times -1 gets me to -3x. So my area is a product. 3x minus 7 times x minus 1. Awesome. One more question in this level. Let's look at number 3. This one looks a little bit different. There's only 2 terms now. We're going to start the exact same way as we started the other questions. First ask, is there a GCF other than 1? In this case, no integer will divide 14 and -9 evenly. So no, X that out. Then what this looks like to me is there's only two terms. What we're missing in the middle is that middle x term. So like over here, how there was a negative 10x, we're missing something x in that middle. So what we can do then is we want to look at our special cases. In our toolkit on that last page, we have those 3 special cases at the bottom. What this looks like to me is what we called difference of squares. We had 2 things being subtracted, and they were square numbers. This is what it looks like. So we have to test it. Well, negative 9, or rather just 9 itself. 9 is a square number. 9 is just 3 to the power of 2. But the issue is 14 isn't a square number. I can't multiply any number by itself to get to 14. So 14 isn't a square number. So rather, this isn't a difference of squares. So no, because 14 isn't a perfect square. So then this question right here is non-factorable. We can't factor this any further than what we have. That's level 3. Again, level 3 is a golden standard. We have to be able to factor these questions. Let's go ahead and look at the last level, up to level 4. Same idea here. We're factoring each polynomial completely. So, starting with this first one, we got 6x cubed plus 14x squared plus 4x. Start with that same first question. Is there a greatest common factor? And in this case, there is. So, yes. What I can factor out of each of these 3 terms is a 2x. So if I divide each of these 3 terms by 2x, we get, in the first term, we get 3x squared. The second term, we get 7x. And the third term, we just get 2. Always start by factoring out your greatest common factor. So once we're in this situation, we're going to focus on this right here and factor it in the same way we did all of the other questions. So go ahead and draw your area model, draw your diamond, and let's start filling these out. Up in the top left, we got our 3x squared. Bottom right, that last term of 2. So then in our diamond on top, when we multiply these 2 terms together, we get 6x squared. And then on the bottom is that middle term of 7x. So we're looking for 2 things that multiply to 6x squared and add to 7x. And in this case, we're going to get 6x and positive 1x. So let's fill those in to our missing boxes. Get a 6x there and a 1x there. And then we just need to figure out what's our length and what's our width. So to multiply to 3x squared, I know I'm going to have a 3x and a positive x up here. Then 3x times 2 gets me to 6x. X times 1 is just 1x. So my area as a product here, my length is x plus 2, and my width is 3x plus 1. Do not forget, though, this is not our final answer. We also factored out this greatest common factor from the start. So this 2x swings all the way back and goes out front here. So this is our final answer. And again, you can check this. Multiply everything back out and see, do you end up with where we started? All right, 2 more questions. Let's look at the second one. Same idea. For factoring, is there a GCF? Is there a GCF? And again, in this case, there is. I can divide 2, 20, and 32 all by 2. Our greatest common factor, we can pull out a 2 in front. And what we're left with is x squared plus 10x plus 16. Factor to 2 out of each of these 3 terms. Then we factor as normal. Draw an area model. Make a diamond. Fill these out. Up in the top, we got an x squared. Down in the bottom right, we got a 16. Okay, so where we were at, we factored out our GCF. We had 2 times x squared plus 10x plus 16. We were filling out our area model and our diamond. So up here in the top left, we had our x squared. The bottom right, we had 16. So then in our diamond, up top, we got 16x squared. And then on bottom, we have that middle term of 10x. Looking for two things that multiply to 16x squared and add to 10x. In this case, we have 8x and 2x. So let's fill those into our area model, 8x and 2x. Then we just need to find our length and our width. To get to x squared, we know we're multiplying x times x. X times 8 gives us to 8x. X times 2 gets us to 2x. So then my area as a product is x plus 2 times x plus 8. Don't forget, we have this GCF of 2 that we also have to bring back. So our final answer is this. Boom. Awesome. Last question. We got 20x squared minus 4. Always start with that GCF. Is there a number that I can divide both 20 and 4 by evenly? In this case, yes, there is. 4 is our greatest common factor here. I can pull out a 4, and what I'm left with is 5x squared minus 1. So what this is looking like is a lot like the problem we did up here in level 3. It looks like a difference of 2 squares. We had something squared minus something squared. So we have to check, are each of our terms perfect squares? Are they both some number squared? Well, here, this 1 is 1 squared, so that is a perfect square. Our x squared is x to the power of 2. That's also a perfect square. But then the issue is our 5 out front, no integer times itself is going to get me to 5. 5 is not a perfect square. So is this a difference of squares? No. So then we're actually done. We can't factor this problem any further. So our final answer is just 4 times the quantity of 5x squared minus 1. Awesome. Hopefully that helped. Hopefully you got something from this. I'm going to stop that.